Hola class, what is going on? As you can see here, we have a swimming pool just hanging out here on my property. But you know, this really isn't my property. But we would say that this right here, the swimming pool, would be part of property. But in math, property is not something that you own or are you on. We have different definitions of properties. So let's go ahead and get to it. First, we have the commutative property. And in the commutative property, basically, we can remember it by these words CO. Change order. And basically, if we would take two numbers, like 3 plus 4, if we would change that order, 4 plus 3, it would equal the same thing. Also with the commutative property, it can be with addition, like I just showed, or it can be multiplication. So we could say 5 times 6 is the same thing as 6 times 5. If the 5 and the 6 change order, it still is the same. It probably makes a lot of sense. A lot of the properties we're going to talk about make sense to you, but we want to know what they mean so that we can understand how to use them later on or state why we were able to do something. Our next one, the associative property. I like to say you associate with a different grouping of people. You could take something like 1 times 2 times 3, and we could group some of these together. So we could group the 1 and the 2 together. That would be the same as if we switched our grouping and we multiplied the 2 and the 3 first. So we had parentheses around those. So the associative property says in multiplication, we could also do this exact same thing in addition, that you can change your grouping. So here is our example for addition. So there you have it. And the last property on this slide right now is the distributive property. We've talked about this already before. If we would have something like 11 and then 2 plus 9, we would be taking 11 times 2 plus 11 times 9. Got a little close to the page there, but you guys get my point. So you multiply both the 11 times each number on the inside of the parentheses. It could be a variable as well. The next slide of properties are ones that make a whole lot of sense. They're things that you have not had to think about before. The reflexive property is as easy as saying that A is equal to A. We kind of see our equal sign as being a mirror. If you're going to see your reflection, or the reflexive property, see your reflection in the mirror, you're going to see yourself again. So if A looks in the mirror, the equal sign here, he is also going to see himself with another A. That one's pretty easy, makes a lot of sense, the reflexive property. The next one is the symmetric property. It's saying that if you have a number A, because remember, it is a number because variables represent numbers, so A is equal to B, then we can also reverse it and say that B is equal to A. It makes a whole lot of sense. If 0.5 equals 1/2, then of course 1/2 is going to equal 0.5. We can write it in any order we want. Next one is the transitive property. Basically we're saying if A is equal to B and B is equal to C, then we can conclude that A is equal to C. Because clearly if A is equal to B and B is equal to C, B is equal to both A and C, then of course A and C are the exact same thing. The last part is substitution, another one we've already talked about, but we'll give a kind of mathematical definition here. Basically it's saying if you have A is equal to B and you have an equation for A plus 2, then you could also write that exact same equation as being 4b plus 2. So oftentimes we'll see that as numbers when we substitute in, but we could also substitute another variable if they are the exact same thing. Next up, we have some identity and inverse problems. First of all, the additive identity. So of course the additive is going to mean we are using addition, or we are adding things together using our plus sign. Basically it means what can we add to a number so it stays the same, it has the same identity. So if we would take 5 and we would add what to it would be 0, 5 plus 0 is still equal to 5. So as we can see, our number started as 5, it remained and had the same identity and ended up with a 5 again. But every single time we have an additive identity, we will be adding 0. So we'll be adding 0 every time. The next one, multiplicative identity. You'd think that maybe we're going to multiply by 0 since that's what we did with the identity up above. But this time with the multiplicative, again, that's a fun word to say, multiplicative. Try to say that 5 times fast. That's kind of fun. Multiplicative identity, if we have 5 and we want it to be equal to 5 again, what are we going to multiply by? Well, it would be multiplying by 1. Anything times 1 is itself, so the 5, again, our identity is the exact same in our answer. Our next one, inverse. So again, we have the additive inverse. So if we are additive, it's going to be adding the inverse. So basically, what's the inverse? The inverse is the same thing as the opposite. So maybe that would help you out. So if we would have the opposite, so we would say that if we had 6, what's the opposite of 6? Well, it's negative 6, and it's additive, so we are adding. So 6 plus negative 6 is always going to be equal to 0. So if you add anything and its opposite, you're going to equal 0. Makes a lot of sense. You guys already know that, but we have a certain property that we need to look at for it. Next one is the easiest of them all. The multiplication property is 0. Again, multiplication, and we have 0. Anything we multiply by, so we have a number z. Multiply it times 0, you will always get 0. Basic. We're moving on because you guys already know that one. It's pretty easy. It's the exact same thing that it says in the title of that property. Next one, multiplicative inverse. So if we would, it's also known as the reciprocal. So the reciprocal is a fraction flipped. So if we would have 1/5, the reciprocal of that when we flip it is going to be 5 over 1, which we should know as just 5. So multiplicative inverse, we are multiplying inverses together. So if we would have a over b, the inverse of a over b, or the reciprocal, is b over a. That will always equal 1. So let's give a good example of this. An example would be 3/5 times 5/3 is going to be equal to 1. You can put that in your calculator if you don't believe me. Alright, moving on to the last slide, equivalent expressions. Basically, what that is saying is if we have 2g plus 7g and we would have 9g, if we put an equal sign in between both of them, here we have an expression, here's an expression. If we have equivalent expressions, we have an equal sign. What is that saying? It says that each side represents the same number. So both of these, if we could substitute whatever g is in there, we would end up with the exact same number. So equivalent expressions, pretty basic there. And finally, coefficient. We have talked about it already this year, but we have not given a good definition. If we would have an expression of 4x squared, the coefficient is the number in front. So our coefficient would be 4, the number that is being multiplied by our variable, which would be x. So if we would have negative 5/7 xy to the 4th power, the coefficient is negative 5/7. We could do one more example. If we had 2/3 p, what is our coefficient? The number that's being multiplied in front, 2/3. Alright, head on to your IXL.